may be brighter than the sun, my fellow science lovers, but today's topic certainly isn't. Still, I don't think you fully understand the gravity of our situation. Greetings, my physics friends. This is Natalie Savage here with my trusty flashlight to bring you another episode of 300 Seconds of Science. Trust me, it's gonna get dark. How dark, you ask? Let's just say we're going to need more than a flashlight. That's right, my friends. Today we're talking about black holes. Contrary to popular belief, black holes don't actually suck. At least not any more than the Earth does. Suction is what we call the process of something getting pulled into a vacuum, and black holes are anything but. Objects fall into black holes, just as they fall on Earth. Black holes are actual physical objects in space, just like stars, planets, asteroids, spaceships, and aliens. Well, maybe not aliens, but that's a topic for another time. Unlike these other celestial objects, however, black holes are so densely packed with matter that their gravitational pull is ginormous, much stronger than our sun or any other star in the sky. In fact, the gravity of black holes is so great that not even light can escape it. As such, black holes are invisible to the eye and must be detected by using special radio wave telescopes like the Event Horizon Telescope and observing the orbits and behaviors of objects surrounding it. Or, even though no light can escape the black hole, that doesn't mean black holes can't be responsible for some spectacular light shows. Seriously, hear me out. Sometimes when a black hole consumes all the gas surrounding it, friction with the edge of the black hole causes the gas to heat and glow so brightly it can be seen from across the universe, outshining the entire galaxy it belongs to. This is known as a quasar. As of 2019, astronomers recognized 3 types of black holes: stellar, supermassive, and intermediate. Stellar black holes are the least massive, but they're still over 3 times more massive than our sun, despite being around the diameter of a city. Hence the name, stellar black holes are formed from the collapse of a single but giant star. They grow in size by feeding on gas and other types of matter from nearby galaxies, and the Harvard-Smithsonian Center for Astrophysics says there are a few 100 million black holes in the Milky Way alone. And if that wasn't dark enough for the Milky Way, it gets even darker. Not only is the Milky Way home to millions of stellar black holes, but a supermassive black hole also sits at its center, as is the case with most other galaxies as well. Supermassive black holes are millions to billions of times as massive as the Sun. There are 4 theories astronomers have for how supermassive black holes form. Maybe hundreds and thousands of tinier black holes clumped together. Maybe rapidly collapsing gas clouds are the culprit. Maybe it was a group or cluster of stars all collapsing at the same time. Finally, they could be the result of large clusters of dark matter, a substance of unknown composition only observable through its gravitational effects on other objects. Or it could be aliens. Who knows? But probably not. Black holes, unfortunately, are very different from the theorized wormholes. Whereas the latter would provide somewhat of a shortcut through space, black holes are more of a one-way ticket to nowhere. Black holes dead end at a single point, known as singularity. But we'll get to that later. The third type, intermediate black holes, is basically what the name suggests. Intermediate black holes could form when a cluster of stars collide, forming a chain reaction. Research from 2018 suggests intermediate black holes form the center of dwarf galaxies. X-ray activity observed from 10 of these baby galaxies suggested these black holes were between 36,000 and 316,000 solar masses. Several intermediate black holes forming the same region could lump together at the center of a galaxy, spawning a supermassive black hole. Black holes, no matter the type, consist of an event horizon and the aforementioned singularity. The event horizon forms the mouth, or boundary, of the black hole, and once you cross it, well, like the Eagles put it, if you fell into a black hole, you'd be stretched and spaghettified long before you reach the singularity, which is a single point in space-time where all the black hole's mass is located. There, gravity becomes infinite and the laws of physics stop working. Not even light, the fastest energy source we know of, can muster the force to escape such a strong gravitational pull. Einstein predicted the existence of black holes in 1916 with his general theory of relativity. It was because of this theory that the existence of singularities was proposed, and while we've been able to confirm the existence of black holes by observing their effects on nearby objects, what's inside is still nothing more than a theory. Still, science is built on theories, and while this is one mystery that may never be answered, it is a small piece in the puzzle of the larger universe. Thankfully, we study them safely in the knowledge that Earth, located 26,000 light-years from the black hole at the center of the Milky Way, will not fall in and turn to spaghetti. For more content like this, Be sure to like us on Facebook, subscribe to our YouTube channel, follow us on Twitter, and give us some love on Instagram, all at ZTV 300 Seconds of Science.
This program was produced by ZTV at the University of Akron. Do you want to gain experience in video production, professional social media, or working with real clients? Visit the UA School of Communications online or follow us on social media to learn more. ZTV, make media, make a difference.